Okay. All right, so we're now going to do the most famous demonstration in all of physics because we've now done all the hard stuff, right? So now we did all this, even something we're going to go back and do the hunter and the monkey. Just in case some of you don't believe that X and Y motion is uncoupled, we're going to prove it with this famous demo that everybody has to see once. Let's see. I've seen it many times. Okay, so the idea of this is you have, and it's also just a good practice problem for us to do, is you're on the ground here, you have a hunter with a gun, right? And he's got a gun, and the gun is going to shoot a bullet at V naught, and the angle is theta. And he's trying to shoot a monkey. Oh, why? Why? You can't eat a monkey. That doesn't make it okay, right? So a tree and a branch and the monkey's hanging. Oh, shit. Okay, and there's the legs right there. There's a monkey. Right? So the question is, the hunter shoots, right? And the sound scares the monkey, right? So bang. And the monkey drops. Oh, no. Okay, so the question is, where should the hunter aim? Should the hunter aim right at the monkey? Should the hunter aim below the monkey because the monkey drops? What should the hunter do? So the hunter has seen this demonstration before, so let's say he's going to guess that he should aim right at the monkey, D. Okay? And he knows that the monkey is at a height h. So if he aims right at the monkey, shoots his gun at theta and V naught, does he hit the monkey? That's the question. And will we hit the monkey? That's the more important question. Okay. So what you would want to do is ask yourself, how much are each of these things going to fall? Okay. So let's first look at the time for the bullet to get from here to here. Time for bullet to cross D. Okay, so you look at that and say, which kinematics am I going to use? Am I going to use X or Y? So it's to cross D. D is along the X, so we're going to use X. All right, so then you could say, well, okay, so if I'm going to use X, I'm probably going to use this. X final equals X initial plus V initial XT plus 1/2 AX T squared. All right, and you're going to say, oh, wait a minute. Do we have any acceleration in X? No. This is uniform motion. All right? And we're going to say initially we'll call this the origin. Drop it like it's not there. And final, what is X final then? X final is D. So D is there. So D is the initial X velocity, which is what? V naught cosine theta. D equals V naught cosine theta times T. Right? So the time for the bullet to cross D is just D over V naught cosine theta. Right? So that first time is D over V naught cosine theta naught. I guess we should be saying theta naught. Okay? Now I'm not going to give it a special subscript. You got to get used to this idea in these problems. We find this time. Okay, now we're going to go find this time. And now we find this height. You can be real careful writing subscripts every time, but it often will just throw you off. Okay? So we want to know is, when this follows this actual trajectory, are they going to be at the same place at the same time? That's another big word we use in kinematics problems is, do they hit? Right? Do they hit? So if they hit, then what that really is asking is y of the bullet equal y of the monkey at this time? Because we know at this time, x of the bullet equals x of the monkey. Right? That's what we just calculated. The monkey is always at D, and we just figured out when does the bullet get to D. So what we've got to do is take this time where the bullet's at D and plug it into their two y equations and just see what we get. All right? So let's first do y. Okay, so now we're answering the question, do they hit? Okay, so y, let's do the bullet first. Well, let's see. It's y final equals y initial plus vy initial t plus 1/2 at squared. So the final is the y of the bullet we're looking for. Initial is 0. I won't even write it, right? It started from the ground. Plus vy initial, which was v naught sine theta. V naught sine theta. And then the t that we just did, d over V naught cosine theta. D over V naught cosine theta naught. Okay, so that is Vyit. And then minus 1/2, or plus 1/2, negative 9, well, whatever, negative 9.8. And then this same t squared. Oh my God, d squared over V naught squared cosine squared. D squared over V naught squared cosine squared theta naught. That's where it'll be in y. Let's see, this is negative though, sorry. I kept jumping. Oh no, I put the negative there. I'm trying to do that to help you remember. Okay? That's y of the bullet. Okay? Initial y velocity, it's decelerating down, no initial position, and we plugged in a specific time. Right? The time is in there. There it is, d over V naught cosine theta, d squared over V naught squared cosine squared to the third. Y of the monkey is simpler, right? Y of the monkey starts out at D, doesn't the monkey? Or it starts out at H. Right? So the monkey is at H. That's his initial. He has no initial y velocity. Right? It's not falling at the beginning. It starts out at 0. So it's also plus 1/2 negative 9.8 the same time, d squared over V naught squared cosine squared theta naught. Okay? So the big question is, what does, what is required, I don't know what that says, for y bullet to equal y monkey? So we set them equal to each other and say, what does this tell us? Well, you can see what's going to happen. You set them equal to each other, and these two terms are the same. Those are going away. Right? So we get that V naught sine theta naught over V naught cosine theta naught, and there must be a D there. Yeah, D. D has to basically be equal to H. Right? Oh, the V naughts go away. What's sine theta over cosine theta? Is tangent theta naught. And that's equal to H over D. Not H and D, H over D. So for these things to hit, this has to be true. But what was the initial condition? Oh, that tangent of theta is opposite over adjacent. Tangent theta is H over D. All right? So this is basically saying, mathematically, that if you initially aim right at the monkey and you shoot the bullet, you'll still hit the monkey because the bullet will fall in the same amount that the monkey will fall. And you'll still hit it. And that happened mathematically when we realized these terms are the same. So in terms of the relative height of the two objects, the fact that they're falling doesn't matter because it cancels out. See? Should we prove it? Do we want to do this? Gun, monkey? Yes. Well, we're going to. I don't care if you don't want to. We're going to. Okay, so here's how this works. This is the gun. I have it preloaded with a bullet. There's a bullet, there's like a Teflon plug in there. And when I blow really hard on this tube, this very sanitary tube from like 100 years ago, it's going to shoot out, and it's actually going to break the circuit right here. This little thingy comes open, and that breaks a circuit that stops an electromagnet, and the monkey is held up by an electromagnet. Okay? So that way the monkey drops. It doesn't really hear a sound and freak out. We break a circuit, which breaks the current, which makes the monkey drop. Okay, so now we've got to get the monkey out. Now this year we tried to do something a little bit special. Okay? This year we used to have this monkey that we used here. But this year we decided, you guys are paying a lot of tuition, we actually have a real monkey. We're going to do this with a live monkey. Hold on. Let me get it out here. I'm fucking with it. It's not a live monkey. It's a fake monkey. We wouldn't do it with a live monkey. I'd never get away with it. I think I forgot to turn the current all the way up. There we go. Okay, so the monkey has a bolt in his head, and there's the electromagnet up there, right? And he's going to stick up there like this. Right, okay. Okay, now we don't have to do it this way. So if you've ever seen this before, most people shoot it like a meter because they want to be guaranteed a hit. Right? Now, would you rather be guaranteed a hit, or would you rather see 10 meters and it might not hit? 10 meters, exactly. If you say that short distance, then you need to take a different class. This class is for people that want to do the full 10 meters. Okay. So what I'm going to do now is catch my breath enough, and we're going to shoot, and you just got to watch and see if it hits the monkey. Set your phases for stunned. Okay, here we go. Ready? Can you blow this? I'm tired. No, I got it. Sorry. I'm running around too much. Okay. Nailed the monkey right in the chest. Perfect monkey. Poor monkey. Oh my God. Okay. Sad, sad. Ping pong balls bouncing. It's just pathetic what happened to that monkey. Okay. So that's really all of the... are we in the second half? Yeah. That's really all of the projectiles we're going to do.